An interesting way of transforming geometry in Grasshopper is through a technique called morphing. Using the box morph component, which is located under the transform morph component panel, we can stretch and distort geometry in a very precise way. So let's walk through how to set this up. First off, I'll need some base geometry to apply the box morph to. So for that, I'll just quickly make a sphere in Rhino. Then back in Grasshopper, I'll grab a geometry component from the params geometry component panel. And I'll right click to set one geometry and import my sphere from Rhino. I'll also internalize this data so that copies the sphere into my Grasshopper definition, and now I can actually delete the Rhino geometry. So now I can start setting up my box morph. So box morph takes 3 inputs. The first is the base geometry. Now in our case, we would like to connect that sphere from the geometry parameter, but of course that could be any geometry that you're dealing with either in Rhino or in Grasshopper. Second is a reference box. So this is essentially the bounding box of the geometry that we set in the first input, and we have some different options for how to set this. Now the simplest way would be to just plug in our geometry parameters output into the reference box input, and Grasshopper would automatically figure out the proper bounds of that reference box. A more flexible way, and one that will help a bit to illustrate the morphing process, is to use a bounding box component between the geometry and the box morph's reference box input. So I'll grab that from the surface primitive component panel. And what I like to do here is just take, for the content input of the bounding box, that geometry parameter. The plane XY input, I'll just leave at the default of the world XY. And then I'll take the box as list output and feed that to the reference box input of my box morph. Now, I can see I also get this nice bounding box preview around my base geometry, and that's actually going to help us out in understanding what happens with a box morph. Now, the last input that we need for our box morph is a target box. So this is a shape that will determine how our base geometry gets morphed. So let's just set up a simple center box component, and that's again under the surface primitive menu. And I'll go ahead and add some number sliders so that we can control the size of our center box. And I'll just left click and hit Alt and drag down to duplicate. So I'll make one each for X, Y, and Z. So now I have a box with flexible dimensions, and I can plug that into box morph's target input, and we'll see what happens. Okay, so now I can see I get a copy of my base geometry inside the target box. And where it starts to get interesting is when I change the dimensions of that target box. So let's say I stretch it out and squash it down. So Grasshopper is automatically going to figure out, well, what's the difference between the reference box and the target box, and how can I squish that reference geometry to fit inside the target box? And we can see even a little bit more clearly if we disable the preview on both of those boxes, what's going on with our box morph. Okay, so that's just a really simple way to use box morph to distort your geometry in Grasshopper.